Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, Chemical Bonding. Today we will begin with lecture 16 from the course, but make sure you have watched the previous ones before viewing this one. So the topics we are going to discuss today in this lecture are going to be, first of all, the characteristics of the covalent compounds. Then we would be discussing the differences between the covalent and the ionic compounds. Moving on to the conditions favoring electrovalency and covalency. And finally, we will be discussing the orbital concept of the covalent bond. So we will be beginning with the first topic, that is going to be the characteristics of the covalent compounds. So the first characteristic of the covalent compounds is the physical state. Now you all know in a molecule, the atoms, they are held to each other by covalent bonds. So these covalent bonds, they are quite strong. But what about the molecules which have been formed? How are they held to each other? They are held to each other by weak van der Waals forces of attraction, and these are weak forces. Therefore, the covalent compounds, they either exist as gases or liquids with low boiling points under normal conditions of temperature and pressure. It is only going to be compounds which have high molecular weights which can exist as soft solids. For example, sulfur, which is going to be S8, phosphorus P4 and iodine I2, which have high molecular weights and they are existing as soft solids. Next we have the crystal structure, and the crystal structure for these compounds, it can be a covalent or it can be a molecular. So when we have covalent solids, what is going to be seen is that every atom is bonded to 4 other atoms by single covalent bonds, and this results in the formation of giant structures. For example, we have silicon carbide, that is carborundum, aluminium nitride diamond, and these are therefore going to be hard crystals with high melting points. Whereas the other type is going to be the molecular solids, and in the molecular solids, the molecules themselves being formed by the sharing of the electron pair, therefore being held by the strong covalent bond, but between the molecules there is the weak van der Waals forces of attraction, or it can be a hydrogen bond, and therefore these solids, they are known as molecular solids. And for example, we have for such solids are CH4, that is methane, and dry ice solid carbon dioxide, etc. So the next property is the melting and the boiling points. So melting and boiling points depend upon what? They depend upon the forces of attraction between the molecules. More is going to be the force of attraction between the molecules. More energy we have to provide to separate out those molecules and convert a solid into a liquid into a gas. So therefore, as we know that the covalent compounds, they have weak van der Waals forces of attraction between the molecules. These compounds generally possess low melting and boiling points, the exception being the ones which are forming those giant structures like silicon carbide, diamond and silica, which will be having high melting and boiling points. The next property is going to be electrical conductivity. Now, when is a compound going to conduct electricity? It is going to conduct electricity when they can dissociate into ions, or they have free electrons for the passage of electricity. The covalent compounds, they are neither going to dissociate into ions, neither do they have free electrons to conduct electricity. Therefore, they are going to be generally bad conductors of electricity. But again, there are going to be certain exceptions to the rule. The first being the polar compounds. Polar compounds like HCl, in the solution form, they can dissociate into ions. For example, HCl dissociating into H ions and chloride ions, and therefore these can conduct electricity. Then we have graphite. Graphite can conduct electricity because the electrons are present in this as free electrons as well, and these electrons can pass from one layer to the other. Self-ionizing molecules can also conduct electricity. For example, we have liquid ammonia. So two molecules of ammonia, what do we get from these is one is an NH4 positive ion and one is a NH2 negative ion. So it has dissociated into ions, and this dissociation, because one molecule is causing the dissociation or the ionization of the other molecule, this is called as self-ionization. And because now ions have been formed, therefore they can conduct electricity. Another example is of the water molecule. So water molecule can cause the ionization of the other molecule of water and forming hydronium ion H3O positive and OH negative. And because of the self-ionization, as ions have been formed, therefore water can also conduct electricity. Next property is going to be the chemical reactions. Covalent compounds, they are going to show molecular reactions. That is, it is going to be involving the breaking of old bonds and the making of new bonds. So the next characteristic is going to be the solubility. Now you people know that like dissolves like. So we are going to categorize the covalent compounds into two types, the non-polar ones and the polar ones. The non-polar compounds will be soluble in the non-polar solvents, like we have carbon tetrachloride, carbon disulfide, benzene, which is C6H6, etc. And then there will be polar compounds. Polar compounds are the ones where the electronegativity difference is from 0.9 to 1.8 or 1.7. But these are the ones which are going to be soluble in the polar solvents as well, like we have water, CHCl3, alcohols, etc. Then we have the phenomenon of isomerism, which is shown by these covalent compounds. What is isomerism is something that we have to discuss in great detail when we are going to discuss the course on organic chemistry. But for now, what you can understand is that the covalent compounds, they have covalent bonds. The covalent bonds, they are rigid and they are directional in nature. They can position differently in space, and therefore they can show different spatial arrangement of the atoms, and thus they can exhibit the phenomenon of isomerism, which is going to be a structural and spatial position of these atoms in the molecule. Now that we have a fair knowledge about the ionic compounds and the covalent compounds, let us quickly summarize their differences. So the first difference, which is basically the formation, it is going to be that the ionic compounds, they are formed by the transfer of one or more electrons from one atom to another, whereas the covalent compounds, they will be formed by the sharing of one or more electrons between the bonded atoms. The ionic compounds, they consist of ions, whereas the covalent compounds, they consist of individual molecules. Now the ionic compounds, they are a three-dimensional crystal lattice. They are hard solids and they will have high melting and boiling points. Whereas covalent compounds, they are going to be amorphous in nature. They are going to be powdery substances. If they are forming solids, they will be soft solids. Otherwise, generally, they will be existing as gases and liquids with low melting and boiling point. Now, ionic compounds, they are soluble in water, like dissolves like, and they will be insoluble in the organic solvents. Whereas the covalent compounds, they are going to be generally insoluble in water, but they will be soluble in the organic solvents. Again, the exception being of the polar covalent compounds. Then the ionic compounds, they can conduct electricity in the fused state as well as in their aqueous solution, but not in the solid state where they are held to each other by the strong electrostatic forces. But definitely when they are in the molten form or in the aqueous form, they are going to form ions and they are going to conduct electricity, whereas the covalent compounds, they are going to be bad conductors. Then the phenomenon of isomerism, this is not shown by ionic compounds, but it is shown by the covalent compounds. Ionic compounds, they generally undergo fast reactions in ionic form, whereas the covalent compounds, they undergo molecular reactions which are very slow. Now, one more important differentiation I wanted you to remember while we have discussed so many important things is what are the conditions which are favoring electrovalency versus covalency. What is electrovalency? This is going to be the number of electrons an atom has gained or lost during the formation of an electrovalent bond or an ionic bond, whereas covalency is going to be the number of electrons an atom is sharing to form a covalent bond, right? So let us quickly revise what are those points which are going to be very important over here, and these will really help you revise your lectures which we have already discussed. Electrovalency, this will be favored by low positive charge on the cation, whereas covalency, high charge on the cation. Large size of the cation, small size of the anion, low charge on the anion and high negative charge on the anion. Here it will be a small size of the anion, large size of the anion, favored by cations having 8 electrons or noble gas electronic configuration, whereas this is going to be favored by cations having 18 electrons or pseudo noble gas configuration, right? So I hope these points are clear to you. In case they are not, please quickly go back to your lectures and revise those concepts very well. So now the last topic that we have to discuss for this lecture is the orbital concept of the covalent compound, but not the least important of all these. Well, this is going to be a really important topic because the theories that we have to discuss further, the valence bond theory, the molecular orbital theory, they are going to be revolving around this concept. So please do understand these things very well. This will really help you in the understanding of those theories over here. Okay, so first of all, what you have to remember, and you have already learned that one orbital can accommodate a maximum of how many electrons? It is going to be 2 electrons with the opposite spin. One is the spin up and other is the spin down electron. Now, when we have a half-filled orbital, which means that there is going to be 1 electron in that orbital, it will accept 1 electron from another atom to complete its orbital. But this other electron, this should be having an opposite spin, okay? Now, the tendency to complete the orbital or to pair the electrons is the necessary condition for the covalent bond formation. The number of bonds formed by an atom, therefore, this will be equal to the number of unpaired valence electrons. For example, in the case of the hydrogen molecule, hydrogen atom has 1 electron. This means it has 1 valence electron, and that is 1 orbital which is half filled. So this half filled orbital of the hydrogen atom combines with the half filled orbital of the other atom, and there is going to be a sharing of these 2 electrons and the formation of a hydrogen bond, right? So what do we have here is there is 1 unpaired electron, so 1 bond being formed. In case of oxygen, let us see. Oxygen, let us understand the valence shell configuration. It is going to be 2s2 2p4, that means 6 electrons in the valence shell. 2 electrons filling the 2s orbitals, 2 electrons filling the 2px, 1 electron in 2py and another in 2pz, right? So this means that there are 2 valence electrons. So how many bonds oxygen can form? It can form 2 bonds, right? So when an oxygen atom is combining with the other oxygen atom, there is going to be a combining of these 2 orbitals which are half filled. And what do we get is that there is going to be an overlapping of these orbitals, and what we will be forming is a oxygen-oxygen double bond, right? So 2 bonds in relation to the 2 half-filled orbitals. Now, one very important thing over here is that you have to remember that if outermost orbit has empty orbitals, then the covalent bonds, they are formed in excited states. What do I mean by that? Well, the paired electrons, they get excited in the subshells of the same shell to form a maximum number of unpaired electrons so that it can form a maximum number of bonds and complete its electronic configuration. Okay, so the maximum covalency is being shown by an atom in its excited state. The energy required for the excitation of electrons is called as promotional energy. For example, let us consider the formation of PCl5. We have chlorine with the valence shell configuration of 3s2, 3p5, and there is one electron which is unpaired. Then we have phosphorus, which is p15. So here what we'll be having is 5 valence electrons for phosphorus, which means that there is 3s2 and 3p3. So the covalency that phosphorus can show in the normal ground state is a covalency of 3. Whereas when phosphorus is in the excited state, one electron from here is going to go and move into the d orbital, right? And when it goes into the d orbital, how many unpaired electrons would be having? Phosphorus would be having 5 unpaired electrons in comparison to the ground state where there are just 3 unpaired electrons. And now these 5 unpaired electrons can combine with 5 atoms of chlorine which have one orbital halfway, and these are going to overlap with each other and show a covalency of 5 in case of phosphorus, right? I hope you can understand. Chlorine has one valence electron, so it has to combine with one phosphorus atom to complete its orbital over here. Phosphorus in this case would have formed PCl3, but now in the excited state it is forming PCl5 with the covalency of 5. Right? So this is what we have as far as the orbital concept. This is something that we have to discuss further. A lot of discussion pending up. Just a general concept that you have to understand is what I wanted over here. So that would be all for this lecture. Now one another thing before we can move on to the other theories is going to be the characteristics of the coordinate compounds. Okay, so we will be discussing more examples of the coordinate bond which we have been seeing in between while we were discussing the lowest structures. So see you again for that lecture. I hope you've enjoyed this one. So please do click on the like link if you have liked this lecture. Also, if you have not subscribed to the channel till now, please do that, and also click on the bell icon so that you get a notification as and when we put up a new lecture for you, a new course for you. All your queries most welcome in the comment section, or you can mail them to us at h2ochemistry@gmail.com. See you again. Have a nice day. God bless you.